Unit 1, Lesson 6, Part 2, Rational Numbers, Changing Fractions to Decimals. Long division is a standard method for converting a fraction into a decimal. Because a fraction represents division of the numerator by the denominator, long division is used to do exactly that. You'll see that you put the denominator on the outside, the numerator goes on the inside, and when you divide the numerator by the denominator, you will get the number as a decimal number. There are two and only two possible outcomes when converting a fraction into a decimal. First outcome, the decimal will terminate. In other words, the long division eventually ends and with remainder 0. Option 2, the decimal will repeat a block of digits. The length of the repeating block will be less than the magnitude of the denominator. Remember, magnitude means size of. The long division will begin to repeat the same sequence of digits. So we're going to do some examples here in the notes. Convert each fraction into decimal form using long division. Write answer in exact form. Example 145 in your notes. 4/9. You're going to set up in long division form 9 going into 4. And I don't know how many zeros we're going to need yet, so I have it available. But we start, 9 goes into 4 0 times. Well, there you go, it's just 0. So we're going to go to the next, 9 goes into 40. Well, 9 times 4 is 36, and 9 times 5 is 45. So 9 times 5 gets a little too big. So we're going to do 9 times 4, and then bring down the 36. Now we're going to subtract. 40 minus 36 is 4. Then we bring down the 0, and we're going to try putting 9 into 40 again. Now, this may look familiar. We've done this before. We've put 9 into 40 here once, and we're trying to do 9 into 40 here. We're starting to repeat ourselves already. If we are to continue doing this, we will continue to get the same thing over and over again. It's just going to keep giving us 40. So once we realize that we are getting the same thing here that we've had before, we are actually done. So this is 0.4, and it does repeat. Okay, so 0.4 repeats. So in our, you would have worked it out right here on the paper, on your paper, doing the long division. But the answer here is going to be 0.4 with a repeating bar over it. You have to excuse me, this is not working very well. Let me try that again. 0.4 with a repeating bar. And that works. Okay, that is 4/9 written as a decimal. Now let's go to -2 3/4. On this one, you can ignore the -2 as far as the division is concerned. It'll come up as part of the answer. But leading up to that answer, we are going to want to just keep it to the side and remember it. But we're going to do 3/4. Now 3/4, that's going to be 3 as the numerator, 4 is the denominator, so 4 goes into 3. Now as we start going through this, 4 goes into 3 0 times, great. 4 goes into 30, well, not quite 8 times, it's only 7 times. And 7 times 4 is 28. Then we do our subtract, and we get a remainder of 2. 30 minus 28 is 2. Next, we bring down the 0. I guess these are usually, we do a subtraction bar there. It's not the easiest thing to do in the program I'm doing, so I'm not going to put it at this point. And we get 2. Bring down the 0, 20. 4 goes into 20 5 times. And then 5 times 4 is 20. And when we subtract down, we do get remainder 0. Remainder 0 means that's it. It doesn't go any further than that. It is 0.75. So 0.75 is what 3/4 is. We had -2 3/4. So this is -2.75 as the answer. So of course you'd have your long division work here, and there's the answer. Okay, 1 3/7. Let's do that one. We're going to ignore the 1 for now and come back and get it in the final answer. We're going to take 3 divided by 7. 3 divided by 7. Okay, first 7 goes into 3 0 times. All right, that's pretty obvious. 7 goes into 30 4 times. 4 times 7 is 28. Now we just continue down doing the long division process until it either ends or it starts repeating. 30 minus 28 is 2. We're going to bring down a 0. 7 goes into 20 almost 3 times, but it's only 2. So 14. 7 times 2 is 14. We'll do 20 minus 14 and get 6. This one's gone on longer than any of the others we've had. So this 0 got brought down. We have as many zeros out here as we want. So 7 goes into 60. Well, 7 times 9 is 63. It doesn't go in 9 times. It's going to be 7 times 8, which is 56. And 60 minus 56 is 4. I don't see any repeats yet. We bring down a 0. See, we've done 30, we've done 20, we've done 60, we've done 40. Nothing's repeated yet. 7 goes into 45 times. And 5 times 7 would be 35. And when we subtract there, we get 5. Bring down a 0. Have we done 5 before? Well, 50, 40, 60, 20, 30. No, we have not. So 7 goes into 50 7 times. 7 times 7 is 49. 49 minus 1 is, or 50 minus 49 is 1. Bring down a 0. And 7 goes into 10 once. I'm going to have to zoom out here a little bit to get this one to work. So 1 times 7 is 7. When we subtract, we get 3 as our remainder. And when we bring down the 0, we now are doing 7 into 30. We have done 30 before. We are going to start repeating at that point. So if we do the 30, we're going to get 4 again, this same 4 right here. And then after that, we'd end up with a remainder of 2. We do 20 and we get a 2. So it's going to be 4, 2, 8, 5, 7, 1, and it's going to repeat that. So after doing all that long division, it's 1 point, the 1, we had the 1 there, 4, 2, 8, 5, 7, 1. And then all of that's repeating. So I'm going to put a repeating bar above it. All 6 of those digits repeat. Now, a little thing I want to mention about how long it takes to repeat, because 7 took a long time. It will always repeat with fewer places than the number you're dividing by. And there's a really good reason for that. If you think about 7, when I'm dividing by 7, there's only 7 possible remainders. One of them is 0. You've got a remainder 1, a remainder 2, a remainder 3, 4, 5, and 6. So I want you to notice here, we had a remainder 2. Let's see, we had the remainder of 1. We had the remainder of 2. 3 is what we started with, and it was the one we decided to end with as well. 3. We had a remainder of 4. The remainder of 5 happened, and the remainder of 6 happened. So when we divide by 7, we got the maximum length of the repeating digits because every remainder happened. And it will always start repeating or terminate in that many digits, in this case 7. Okay, let's write negative 2 and 1/4 as a decimal. Okay, first, we're going to have negative 2 point something. Now, 2 and 1/4, 1/4 should be one of your memorized ones, because 1/4 is a quarter, and a quarter is 25 cents. So this should just be negative 2.25. And if you have some memorized ones, go ahead and use them. Okay, some additional examples. 5/11. Let's go over back to this. We're going to do 5/11. 11 goes into 5. 11 goes into 5 0 times. So 11 goes into 50 4 times. 4 times 11 is 44, and we get a remainder of 6. Okay. 11 goes into 60 5 times. 5 times 11 is 55. We get a remainder of 5. Bring down a 0. Now, at this point, you should recognize that we are back where we started. We were trying to do it into 50 at the beginning, and we're trying to do it into 50 again. So if we do it again, we're going to get 4 again. So this would be a 4, 5, 4, 5, 4, 5, etc. It would just continue like that forever. So with that in mind, we know that the answer is 0.45 with the 4, 5 repeating. So I'm going to put the repeating bar over top. And that would be the answer on that one. Okay, write the rational number as a decimal. Okay, -6/5. Let's go back over here and try this one. Okay, we're doing 5 into 6. And actually 5 goes into 6 one time. So let me ignore the mistake here. Okay, 1 times 5 is 5. We get a remainder 1. And we bring down the 0. 5 goes into 10 twice. 5 times 2 is 10. And we're at remainder 0. We get to remainder 0. That's great. We're done. The answer, 1.2. Okay, next example. -7 3/8, written as a decimal. Okay, we're going to do the -7. And then we're going to go calculate the 3/8. So we're going to take 8 into 3. 8 goes into 3 0 times. 8 goes into 30 3 times. 3 times 8 is 24. And 30 minus 24 would be 6. We can bring down the 0. 8 goes into 67 times. 7 times 8 is 56. 60 minus 56 is 4. We're going to bring down a 0. Looks like we need another one. 8 goes into 40 exactly 5 times. 5 times 8 is 40. So we get our remainder 0. So 3/8 as a decimal is 0.375. So this answer is -7.375. Okay, next, -3/11. Okay, we're going to take 11 into 3. 11 goes into 3 0 times. 11 goes into 30 twice. And 11 times 2 is 22. 30 minus 22 is 8. I'm going to go ahead and bring down the 0. 11 goes into 80 7 times. And 7 times 11 is 77. So 80 minus 77 is 3. We're going to bring down the 0. Actually, at this point, I recognize that I started at 30 and I'm ending at 30. If I ask how many times 11 goes into 30, I'm going to get the same 2 again. And then I'll get a 7 after it with the remainder 80, or 8. And then it's just going to go 2 7 forever. So -3/11 is -0.27 with the 2 7 forever repeating.